Alright, so our inspiration for this lab was last time I drank some lemonade, it was super acidic, and it was burning the inside of my esophagus, and I was getting all kinds of heartburn and stuff, and I was like, man, I need to neutralize this, and I was like, but which antacid tablet should I use? So the point of this lab is to figure out which form of antacid, liquid or tablet, is better for neutralizing that lemonade, and our control variables are the acidity and the amount of lemonade we're titrating with, and the independent variable is the form of the antacid. The dependent variable is the amount of the antacid, or the cost of the amount of the antacid required to neutralize the lemonade. And the standard of comparison is the titration with NaOH. Oh.
Hey guys, so in order to help Aaron with this heartburn, we're going to titrate lemonade with different antacids. The antacid will serve as a base and lemonade will serve as the acid. An important concept we're going to use is acid-base titration, and we're going to use stoichiometry.
Okay, so to set up the experiment, first we're going to use the antacid solution and we're going to put it into the burette. And then for the lemon juice, we're going to put it in the beaker and put on the stir plate. And then for the hypothesis, we predicted that the tablets will be more efficient and effective because the liquid antacid is more diluted with water. And then to interpret the data and the results, we're just going to look at whenever the pH is 7 on the graph and how much antacid was used.
Alright, so we got a lot of materials here. First we have this beaker. Grabbed a nice fresh lemon, cut it with a $5,000 handmade knife, and then we had 50 mils of lemon juice, and then we grabbed some sodium hydroxide pellets because this is going to be our base that we're using to titrate with. We used sodium hydroxide, put it in the whey boat, or scooped it into the whey boat, and then put it in 50 mils of distilled water, mixed it up with the stirring rod, made it dissolve, added 50 more mils of distilled water.
Yeah. Right now, I'll be adding 5 grams of sugar to our
Lemon juice. And we're going to be using a stirring rod to mix.
Wait, I want to look at mine.
What?
Hey, y'all have your own page, no? It's right here.
So we put the NaOH inside the burette. This is the burette stand. And we have the pH probe to measure the pH. And we have our lemon juice in here with our stirring rod. And we have the stirring plate going on. We also have log of probe right to calculate the pH.
Okay, so right now we are going to start titrating the lemon juice with the NaOH. Make sure you press collect on the logger probe before you start.
I was going to use I don't know, I was going to use this to actually do a
Right, and we're going to start titrating it.
Oh.
On Zoom in.
Okay, towards the end of that titration, the NaOH and the lemon juice turn a neon color.
Oh, look at them games.
Come on, you're right there. Go. Oh. Yo, that's
Right now, we're dissolving the crushed antacid tablet powder into solution using a stir plate.
Okay, right now we're just filtering out the antacid so it won't get stuck in the bread. Yep.
Alright, putting the antacid solution into the burette.
Okay, now we're just titrating the lemon juice again. Okay, click collect.
Whoa. Look at these huge conglomerates of... Oh, they broke apart.
Just let it go, let it go.
Let it go.
Zoom.
So according to the graph, we got wrecked pretty hard and the experiment kind of failed. So what I'm going to do is I'm going to take this pH sensor. Help me shoot it.
They should add an entirely separate page for that.
Come on. Alright. And I'm going to put it over here. We're going to see what the pH goes to. Look at the graph. As you can see through the graph, the pH of this antacid is not even 7.
So, failure. Alright, so we got the liquid antacid here. Diluted it in 50 mils, made 100 mils of the solution, and we're about to titrate this lemonade with this antacid and see how good it is. And then we'll put it on another graph.
There you go. Oh yeah, that's steady.
Read that.
No,
5.
the variable is we change 1.
Yeah, got it.
Your variables are your differences.
So right now I am mixing the antacid liquid with a stirring rod and it's titrating with lemonade at the very bottom. And now we watch the graph. So right now our hypothesis is not doing so hot. The pH is barely rising and has not hit equivalence point. I'm a little triggered.
Okay, so based on the graph, for the liquid antacids, the titration was not a success. So right now we're just finding the pH of the liquid antacid itself, and based on the pH, it looks pretty low. Yeah.
Something went wrong.
So the antacid tablets was not able to dissolve fully because it has some insoluble compounds in it. So then what happened was also the pH was not able to achieve 7 because it wasn't effective enough. So we just decreased it to pH equals 4.
Okay, so for our experiment, we learned that antacids don't really titrate acids the same way that typical bases like NaOH do. So our graphs never really look like normal titration graphs. For general experiments, we learned that you always have to overestimate how much time you think you need for something, because usually something goes wrong and you'll need that extra time. In terms of the scientific method, we learned that observations are very important and we really needed them to figure out what to do after something went wrong. And for the chemistry, the acids create hydronium ions while the antacids create hydroxide ions, and the hydroxide reacts with the hydronium to create water, which is a neutralization reaction. For practical applications, anybody who's experiencing heartburn and is in the market for antacids would really want to find which one's most cost effective.